So that's our classification for pure substances. We break it down that way. Now, what if they're not a pure substance? Okay. So what happens when we start to get physical mixing only? All right. That's our other category. So instead of having pure substances, we can also have mixtures. In a mixture, we can break mixtures down into two separate categories also. Okay. Let's make sure that we're comfortable with what mixtures are. Okay. So mixtures are anytime we physically put two things together and each substance maintains its own properties, but by blending them together, we get a desired result. Okay. In terms of what we have. We make mixtures all the time. So think about most foods we eat are mixtures. Most chemicals that you use in terms of household cleaning, that kind of stuff, are mixtures. Mixtures can be very macroscopic. Like think of a bowl of M&Ms. That's a mixture. Okay. Mixtures can be very, very, very microscopic. Think of like dissolving salt into water. That's actually a mixture. Okay. So mixtures don't create new substances, but the blended effect give us a desired result. Now, one thing that we can really use to help us classify a mixture versus a compound is this idea of being held together by IMF, okay? And IMF stands for intermolecular forces. Intermolecular forces, okay? IMF is an attractive force between two separated substances, okay? IMF is all over in our world, all right? It's one of the dominating principles that allows us to study chemistry. We have chemical bonds and we have intermolecular forces. A lot of people have talked a lot about chemical bonds. They don't talk much about IMF, okay? So that being said, we'll have a slide later more talking about IMF, but I want to introduce it now because it is a key piece of what would identify a mixture, is that you have these forces that go between molecules that hold things together. They're not a chemical bond, but there's still an attraction there, okay? Now, these mixtures, we have two types. We have homogeneous mixtures. Homogeneous means, or homogeneous, you may have heard that phrase before, it's even distribution. So the mixture happens in such a way that if you were to look at it, it looks like it's the same thing throughout, okay? So let's take, for example, Kool-Aid, okay? Kool-Aid's a great example. Delicious Kool-Aid, like your blue Kool-Aid, your red Kool-Aid, whatever color Kool-Aid you like. Looking at it just with your visual, just your naked eyes, you would think, oh, that's one thing. It's a red liquid, okay? We should know that Kool-Aid is actually a mixture of sugar. There's going to be other colorings in it. There's water in it. So it's a mixture of several different elements and compounds that creates the Kool-Aid, okay? Now, it's not chemically bonded. The sugar does not chemically bond to the water, okay? But it gets dissolved inside there. So what happens is we get this nice even distribution. So those sugar particles blend in evenly. That's homogeneous or a homogeneous mixture. So all of our solutions are going to be homogeneous mixtures, things that you put into solution. Alloys are a solid version of that, okay? So think like brass, bronze, steel. Most of the aluminum that we work with, that we buy and you see in different things is actually aluminum alloys, alloyed with other metals. And what an alloy does is basically you take two or more metals, and you liquefy them. So you get them hot enough to make them molten, and then you actually like pour them together and mix them in really well, okay? It's really no different than baking or cooking, where you like take the batter, the flour, the eggs, and you blend it all up really well, and you get a nice homogeneous cake batter or a homogeneous cookie batter or a brownie batter. I'm getting hungry now. And as a result, once it gets cooked or dries, it looks all even throughout. That's the alloys, the same idea, but for metals, okay? So we get things that look like they're one thing, but really they are a mixture of more than one substance, okay? Solutions and alloys are our best two examples for that. Now, everything else that we blend or mix together is heterogeneous, okay? So for our heterogeneous mixtures, that's anytime we have uneven distribution in terms of what we have going on. So with heterogeneous mixtures, at the macroscopic level, if you look at it, you can see the differences, okay? If you take a look at sand on a beach, they're different. If you take salt and pepper, mix it together, you can see the difference between those things. So anytime you mix things physically, but yet you can identify the different things visually, you have heterogeneous mixtures inside there. Okay, so if we break this thing down, we have our homogeneous ones on one side, and we have our heterogeneous on the other side. Okay, so that's kind of how it breaks down. Now, if we take a look over here, we have all different types of mixtures. Here we have a mixture of two different elements. Okay, we have green versus the orange. Here we have a mixture of two different molecules. Okay, they're still elements. We still have a mixture of elements, but in this case, it's elements in their molecule form. Here we have a mixture of the compound water and a molecule of some other sort. Okay, so here we have a mixture of compounds and molecules together. Here we have a mixture of atoms and molecules. Okay, so lots of different types of mixtures here. At this view level, it's really hard to tell because none of these pictures really show enough to let us know, is this heterogeneous, is it homogeneous or not. Okay, often you'll see people when they draw hetero type of stuff, if they're trying to draw something heterogeneous, they'll put in like, you know, one substance here and here, maybe bond them together like this. And then they'll make an obvious second substance and they'll group them as such. So you don't see even distribution. So you have a lot of your, you know, other stuff around, kind of floating around, but you might have two big groupings that are obviously not evenly distributed. So if you see an image like this you're seeing on my iPad screen right now, this would be something that would give us more of an idea of a heterogeneous idea, because these things definitely are not evenly distributed through this whole scenario, okay? Whereas I would say, you know, this has better even distribution. This is relatively even distribution. This is a pretty good even distribution. I would say this is probably the best of these right here, showing more of a homogeneous nature to it, okay? And again, this really does get down to that microscopic level, because the deeper we look, the less homogeneous things are going to be, okay? Typically, though, and we're trying to classify things, we could base off of what is visible by the naked eye, okay? So if it looks like one thing, it's a homogeneous mixture. If it looks like two or more things, it's heterogeneous. That's simple, okay? All right. We're going to take a look at some microscopic views, and then we have a couple more word walls that we're going to do. But these are things that we're going to be doing in class, okay? So we're going to end the video here. Thank you.